Hello students, once again welcome back to the class. In the previous session, we have discussed about preparation of amines. In that video, we have discussed two process and two methods. Okay, first method is called preparation of amines by reduction of nitro compounds, and second method we have discussed about ammonolysis of alkyl halides. Okay, so in this video, in this session I'm going to discuss about next preparation methods called reduction of nitrates. Reduction of nitrates. So, what do you mean by nitrates? C triple bond N. Okay, this is known as nitrates. Okay, so generally we are called a cyano group. When it acting as a functional group means we call it as nitrates. Okay, reduction means what? Reduction means addition of hydrogen. Okay, reduction means addition of hydrogen or removal of oxygen is called a reduction process. In this reaction or in this method, we are reduce carbon nitrogen triple bond. We get RCH2 and NH2. This is the product. The product is called a primary amine. Primary amine is the product. Okay. Then in this process we are using two molecules of hydrogen gas. Okay, we are adding hydrogen. Hydrogen means addition of hydrogen means is called a hydrogenation process. In this process, we are using palladium, platinum, or nickel based catalyst, and the lithium aluminum hydride is acting as a strong reducing agent. Lithium aluminum hydride is acting as a strong reducing agent. It reduces the carbon nitrogen triple bond and it produces the primary amine is the product. And one more molecule is the sodium amalgam. Sodium amalgam in the presence of ethanol. Okay. This also used as a reducing agent. Acting as a strong reducing agent is used to reduce a carbon nitrogen triple bond. It produces a primary amine as the product. Okay. So this is a reduction of nitrile process. And next method is reduction of amides. Reduction of amides. Reduction of amides. What do you mean reduction? Amide functional group. See here R C double bond O NH2. Okay, this is a amide. This is called amide. Reduction of amides. Reduction means what? Addition of hydrogen or loss or elimination of oxygen is called a reduction process. See here carbonyl group is there. In carbonyl group, one oxygen is present here. Okay, we are going to reduce the carbon oxygen double bond, and we are going to eliminate the oxygen from this double bond. Instead of oxygen, we are going to add two hydrogen. Okay, but because carbon balance is 4, 1, 2, 3, and 4. We are removing these two means we have to add two hydrogen extra. Okay, so this is called a reduction of amides. The reduction of amides produce a amine is the product. See here R C double bond O NH2. It's an amide. Here we are using lithium aluminum hydride. It's a reducing agent. It's a strong reducing agent. Generally, it is used to reduce the carbonyl functional group. C double bond O means it's a functional group means it's a carbonyl. Carbonyl. Okay, it's a carbonyl group. So lithium aluminum hydride LiAlH4 is used to reduce the carbonyl functional group. Okay, carbonyl group, and it produces RCH2NH2. It's the product. It's called a primary amine. Primary amine is the product here. Okay, so the lithium aluminum hydride it provides H minus ions. H minus means what? It is a hydrate ions. Okay. Now discuss the mechanism. Now I am going to discuss about the mechanism. See here. First I am going to take amine C double bond O and NH2. It's an amine. Now it's going to react with the lithium aluminum hydride catalyst. Means in lithium aluminum hydride we have AlH4. It's going to provide H minus ion. Okay, H minus ion means, see here, this bond it's made up of two electrons. When hydrogen leave from the place, it will take two electrons and leave from the place. It will produce a H minus ion. It's called a hydride ion. Now come to here. In this amide, carbon and oxygen is there. Carbon is less electronegative than oxygen. Oxygen is more electronegative. So it withdraw the electron from carbon. So carbon is going to lose its electron. So it get bears partial positive charge and oxygen bears partial negative charge. Among the two species, carbon and oxygen, carbon is electron deficient. Okay, why? Because it's lost its electron. It has a low positive. So the hydride ion is going to donate its electron to the carbon. When hydride is going to donate, carbon means carbon valency shifted to 5. 1, 2, 3, 4. Already 4 is there. 4 bond is there. Now hydride is going to approach means the valency will be increased. So one of the double bond is break comes out. Okay, and it produce R C. I'm writing like this: C O new one hydrogen N H 2. Okay, and Al H 3 minus. Okay, now this nitrogen is going to donate its lone pair of electron to the carbon. Okay, it's going to donate the lone pair of electron to the carbon. Why? Because oxygen is more electron withdrawing group, so it will withdraw electron from continuously from oxygen. Carbon it becomes electron deficient, so the nitrogen is going to donate its lone pair of electron. Now the bond is going to eliminated from here. Okay, then we get R C H. Already your bond is there. Bond. Now it's created a new bond. Okay, and it becomes NH2. Okay, R C H NH2. It's called an imine. Okay, it is called an imine. Okay, in Al. Okay, see here now. Carbon is going to donate 2 electrons. It lost its electron. Okay, it lost its lone pair of electron. So it has a positive charge in it. Okay, it has a positive charge on it. Now, carbon, nitrogen. In carbon and nitrogen, nitrogen is more electron negative. Okay, so it withdraws the electron from carbon. It withdraws the electron from the carbon. Okay, then and also it's a imine is a highly unstable species. Unstable. Okay, it is highly unstable. Okay, then what we get? We get R C H N H 2. Now carbon lost its electron, so it has a positive charge. Now see the Al H3. I am writing like this. Now again one more hydride ion is formed here, H minus. The H minus is going to add here. Then we get RCH2NH2. This is the product. This is called a primary amine. From this method, we can synthesize primary amine. This method is called a reduction of amine. See here, initially carbon group is there. Now it's CH2. Okay, the carbon double bond O bond is reduced here. Okay, so this process is called a reduction of amides. Next, we are going to discuss about Gabriel Dalabine synthesis. Okay. Fifth process called Gabriel Dalabine synthesis. Okay, Gabriel Dalabine synthesis. Okay, Gabriel thalamide synthesis, this method is used for the preparation of primary amines. Particularly, it is used to preparation of alkyl amines only. Okay, not aryl amines. Aryl amines means what? Benzene-based compounds. Okay, so it is mainly used to prepare the aliphatic amines. Okay, aliphatic primary amines. It's very important. Aliphatic. It is used to aliphatic primary amines. Aliphatic primary amines, this method particular. Okay, primary amines only we can synthesis from this process. Okay, and aromatic primary amines we can't synthesis from this form. Okay, aromatic primary amines we can't synthesis. We can't synthesis by this method. Okay, so I will discuss the mechanism. Before going to discuss the mechanism, the starting product of this mechanism. Okay, the starting reactant is thalamide. Okay, see here, this is the structure of thalamide, the starting material. C double bond O, C double bond O, N H. Okay, so this is the structure of thalamide. This is the starting material for Gabriel thalamide synthesis reaction. Okay. Okay, so this is the starting material for this Gabriel thalamide synthesis reaction. It is one of the very important process, and one more process is that it is a Hofmann bromide degradation reaction. These two reactions are every year they ask the question, so it's very important. Okay, so before going to discuss the mechanism, the Gabriel thalamide synthesis mechanism, I'm going to discuss how to prepare the initial product. Okay, thalamide. So starting material is for preparation of thalamide. Phthalic acid is the starting material. Phthalic acid is the starting material. Okay, phthalic acid is the starting material. When phthalic acid is undergo ammonolysis process, what do you mean by ammonolysis? Addition of ammonia is called the ammonolysis process. See here, I'm going to add ammonia. Okay, I'm writing ammonia like this: NH3, NH3, on lone paragraph. Okay, see here, OH and H, OH and H. 2 molecules of water will be eliminated, and what we get? Remaining terms. C double bond O, C double bond O. Remaining water molecules are eliminated. Remaining term is NH. Okay, and this is the starting material for Gabriel thalamide synthesis. Okay, what is called? This name is thalamide. Okay, it's called a thalamide. It's called a thalamide. Okay, from this thalamide we can synthesis the primary alkyl amine. We are going to synthesis primary amine. Let's discuss the process. So mechanism of this reaction. Okay, so roughly 4 steps கொடுக்கிறேன். Okay, mechanismல நம்ம என்னென்ன rules வந்து ஃபாலோ பண்ணனும். The first method, அதாவது first step என்னன்னா activate the complex. Activate the reactant. அதாவது thalamide நம்ம ஆக்டிவேட் பண்ணனும். Activate the reactant. And second method is the addition of nucleophile. Reaction with alkyl halide. Okay, and third one, reaction with nucleophile attack. Okay, reaction with KOH. Okay, and the last fourth method is a proton transfer. Proton transfer. Okay. These four steps are involved in the mechanism of Cabriel carbonate synthesis reaction. Okay, so see the mechanism in the first step. Activate the thalamide. So what is the structure of thalamide? So this is the structure of thalamide. C double bond O, C double bond O, and N H. Okay. So see here, this is the hydrogen. Okay, the hydrogen is a highly acidic in nature. Why? Because it has a 2 electron withdrawal group. Okay, carbon is a highly electron withdrawal group. It withdraws the electron from the nitrogen. So it is a highly acidic in nature. The proton. Okay, it is a highly acidic proton. Okay, it is a acidic. So in the group நம்ம என்ன பண்ண போறோம் activate பண்ண போறோம். We are going to activate the complex with the adding of potassium hydroxide or sodium hydroxide. The reaction with the potassium hydroxide. When it will dissociate into K plus and the OH minus. Okay. Now the OH minus abstract the proton from here and it converts into water molecule. So remaining we get like this product C double bond O, C double bond O, N, okay, N K plus, N minus and K plus. Okay. So this compound is acting as a nucleophile. Why? Because nitrogen has a negative charge, so it is acting as a nucleophile. Now this nucleophile is going to react with the alkyl halide. Okay, alkyl halide may be any other CH3Cl. Okay, so it is an example for alkyl halide. In alkyl halide, carbon is electron deficient and chlorine is an electron rich species. So it has a dual positive charge and it has a dual negative charge. Okay, now the nucleophile is going to donate its electron. The nucleophile is going to donate its electron to the deficient. Okay, deficient carbon. The nucleophile is going to donate its electron to the deficient carbon. It becomes, okay, the Cl is eliminated out from here. We get what we get. See here, the second step. Now the nucleophile is going to attack the methyl group. Okay, why? Because it is an electron deficient, so it is a dou positive charge and it has a dou negative charge. So the Cl is going to eliminate it from here. Then we get the product like this. Okay, C double bond O, C double bond O. Okay, remaining N. Okay, NCH3, NCH3 plus what we get here is Cl and here is K. What we get? KCl. Okay, potassium chloride we get. Then next, attack of nucleophile. Attack with the nucleophile. So here going to take here nucleophile is OH minus. Okay, the nucleophile now it's going to attack electron deficient carbon. Why? Because in carbon and oxygen, oxygen is more electron negative than carbon, so it will withdraw the electron from carbon. Okay, withdraw the electron from the carbon, so it has a partial negative charge and the carbon has a partial positive charge. Okay. So the OH minus is going to attack the carbon. Okay. Now the double bond is leave out here. Okay. Then we get bond like this. C double bond O, C single bond O, OH here minus and N CH3. Okay. So this is a bond. Now the OH minus again is going to inside the ring and the carbon nitrogen. Okay, the carbon nitrogen bond is going to break. Now it produce C double bond O, N CH3 and C double bond O, OH. Okay. See here, now the nitrogen take the electron from this bond, so it has a negative charge. Next step, protonation, proton transfer. Okay, proton transfer. In proton transfer, the H, okay, the H is moved from here like H plus. Okay, it move from here, so we get here minus charge, the plus going to reach here. Okay, then it produce the compound like this C double bond O N H C H 3 C double bond O minus. Okay, now it has in this solution, it has a K plus, it's a salt. Okay, produce a salt. And next step again, next step is we are going to react with the KOH. Another molecule of KOH. Okay, the KOH, the OH minus is going to now approach the carbonyl group. The carbon double bond is breaking down and it has a negative charge here. Again, the negative charge come to here. Now, carbon nitrogen bond is breaking. Now, it produce C double bond O H, okay, OH and C double bond O minus and K plus N H C H 3 minus. Okay, now next step is what? Proton transfer. The proton is transferred from here to here and it produce what is the product? CH3 NH2. What we get? This is a primary amine. Okay, this is a primary amine. So from this process is called a caprial phthalate synthesis. Okay, from this method we can get primary alkyl amine. Okay, one more time I will explain the reaction. Okay, so first initial we had a phthalamide. Okay, we have phthalamide here. So phthalamide like this. In phthalamide we have N hydrogen. Okay, now for activity in the complex we are reacting in the basic medium. The basic medium is KOH. Now the hydrogen is abstract or get the hydrogen from here, the OH group, and it produces a nucleophile N minus and K plus. Okay, the nucleophile is going to react with the alkyl halides. In alkyl halide, methyl and chlorine is there. Chlorine is more electronegative than carbon, so it withdraw the electron from here. Okay, it withdraw the electron from here, so it carry the partial negative charge and carbon has partial positive charge. It becomes electron deficient, so the nucleophile is going to donate its lone pair of electron to the carbon. Okay, then at the same time the Cl is move up from this complex. Now we have this compound. Okay, this compound. Next, we are going to react with the KOH. Here KOH is acting as a nucleophile. Okay, KOH is acting as a nucleophile. The nucleophile is going to donate the electron to the carbon, the deficient carbon. Okay, among the two, carbon, oxygen is more electronegative than carbon. Okay, so carbon it's a loss its electron, so it has positive charge. Okay, now the nucleophile is going to attack the carbon, and the carbon oxygen double bond is going to break it down, and it produce bond like this. Okay, and see here again the electron move into carbon. Now carbon nitrogen bond, let's break it down. Okay, then it produce this compound. Okay, it produces this compound. And next here is a proton transfer. Okay, here the proton transfer going to take place here. So in the proton, இங்க போய் நடக்குது. சோ இங்க நடக்கும்போது what we get this product. நெக்ஸ்ட் ஸ்டெப்ல என்னது அகைன் ஒரு KOH ஓட ரியாக்ட் பண்றோம். இந்த KOH ல OH group is acting as a nucleophile. The nucleophile is going to approach the carbon. Okay, deficient electron deficient carbon வந்து approach பண்ணும்போது இந்த கார்பன் கார்பன் டபுள் பாண்ட்ல இருக்க கார்பன் ஆக்சிஜன் இருக்க டபுள் பாண்ட் one of the bond உடைஞ்சு மேல போகுது. The negative charge on oxygen and again the negative charge வந்து உள்ள வரும்போது it comes here the carbon hydrogen bond it's break it down. Okay, break ஆயிட்டு நமக்கு என்ன கிடைக்குது அப்படினா NH okay NHC minus CH3 இப்படி கிடைக்குது. ஓகேவா? Here next step again proton transfer நடக்கும். So இங்க இருந்து proton transfer நடக்கும். Okay, then we get இங்க என்ன K plus okay KCl இருக்கக்கூடிய KOH இருக்கக்கூடிய K plus இருக்கும். So இது என்ன சொல்றாங்க salt அப்படின்னு சொல்றாங்க. Okay, this is called salt. And finally we get CH3NH2 is the final product of this reaction. The reaction is known as Gabriel Thalamide synthesis. Okay, so it's very important guys. And in the reactions வந்து நமக்கு only primary amines அதுவும் primary aminல alkyl amine. Okay, alkyl amine மட்டும் தான் நமக்கு ப்ராடக்ட்டா கிடைக்கும். ஓகேவா? So remaining concept we are discussing in the next class. Thank you so much.